Have you ever wondered what anomalies in database systems are and how they can affect your data? Well, anomalies refer to those pesky inconsistencies, errors, or unexpected behaviors that can sneak into your database due to flaws in design, usage, or implementation. These unwelcome guests can lead to data integrity issues, causing inefficiencies and making it a headache to maintain and query your database. But don't worry, these anomalies aren't random. They generally fall into three main categories that we're going to explore: insertion anomalies, update anomalies, and deletion anomalies. Each of these has its own unique way of causing trouble, and understanding them is the first step to maintaining a clean and efficient database. So stick around as we dive into the fascinating world of database anomalies. In this video, we'll delve into the three main types of anomalies: insertion, update, and deletion anomalies. Let's start with insertion anomalies. These occur when it's challenging or impossible to add data to the database without violating integrity constraints. Picture trying to insert a new record into a table, but you're stopped in your tracks because certain required fields cannot be left empty. You have the data that needs to be added, but the database design won't allow it. Frustrating, isn't it? Or consider a different scenario. You're entering data about a new product that your company is selling. The product is unique, but it's made by a manufacturer that's already in your database. Despite this, you find yourself having to re-enter the manufacturer's details just to accommodate the relationship between the product and the manufacturer. This is redundant data entry, and it's another classic example of an insertion anomaly. Now, why are insertion anomalies a problem? Well, they can create several issues. For one, they can lead to inefficiencies. If you have to enter redundant data every time you add a new record, that's a lot of wasted time and effort. Plus, there's the risk of inconsistency. If the same data exists in multiple places, and it gets updated in one place but not the others, you've got inconsistency on your hands. But more than just inefficiencies and inconsistencies, insertion anomalies can create serious data integrity issues. If you can't add a new record because of a required field that you don't have data for, you're essentially being forced to either leave out important information or make up data just to fill in the gaps. Neither of these is a good option. So what can you do about insertion anomalies? Well, that's a topic for another scene, but the short answer is good database design. By thinking carefully about your database's structure and by using techniques like normalization and the proper use of keys, you can minimize the risk of insertion anomalies and keep your data clean, consistent, and reliable. Insertion anomalies can lead to inefficiencies and data integrity issues, which is why it's crucial to address them. Next, we have update anomalies. These occur when updating data in the database leads to inconsistencies or unexpected outcomes. It's like a domino effect. One small change can lead to a series of unintended events that can compromise the integrity of your data. Let's dive into some examples. Imagine you're managing a database for a large company with multiple departments. Each department has a manager, and this manager's details are stored in every employee's record within that department. Now, what happens if the manager changes their phone number? You'd have to update this information in every single record. But what if you miss one, or perhaps make a typo in one of them? This is a classic example of an update anomaly. The change isn't uniformly implemented, leading to inconsistencies in your data. Here's another scenario. Suppose you're updating a common attribute like the address of a branch office that appears in multiple records. If you don't update all the related records, you might end up with some employees linked to the old address and others to the new one. This discrepancy can cause confusion, miscommunication, and even serious operational issues. So you see, update anomalies can be quite a hassle. They can create a mess of your data, leading to misinformation and misinterpretations. These anomalies can also make it difficult to maintain the database over time, as inconsistencies can pile up and become increasingly complex to resolve. To avoid these issues, it's crucial to manage your data with precision and consistency. Consider using tools that allow for bulk updates or cascading changes, ensuring that all related records are updated simultaneously. Regular audits and data checks can also help spot and rectify inconsistencies before they become a major issue. In conclusion, update anomalies can lead to data inconsistencies and errors, highlighting the importance of careful data management. Remember, in the world of databases, even the smallest change can have a big impact. So, Always be mindful of the potential ripple effects your updates might cause. Lastly, we have deletion anomalies. These occur when removing data from the database results in unintended loss of information. Deletion anomalies can be particularly destructive, as they can lead to the loss of valuable data that was not intended to be removed. For instance, consider an example where we have a database that stores information about books and their authors. We have a record of a book written by a particular author. Now, if we were to delete the author's record, should the book record also be deleted? If the book record is deleted along with the author, we lose valuable information about the book, which is a deletion anomaly. Another example of deletion anomalies can occur when a record is the sole source of certain data. Let's say we have a database that stores information about employees and their departments. Each department has a manager, and this information is stored in the employee record. Now suppose we delete the record of an employee who happens to be a manager. If we don't have another source for the manager's information, we lose this vital data when we delete the employee's record. This loss of necessary information is another form of deletion anomaly. These examples illustrate how deletion anomalies can result in unintended data loss. It's not just about losing the data we intended to delete, but also about losing the data we didn't intend to lose. That's why it's so important to handle deletions carefully. There are a few strategies to handle deletion anomalies. One is to use cascading deletes, which allows for the deletion of related records when a primary record is deleted, but only when it's appropriate to do so. Another approach is to design the database in such a way that every piece of data is stored in at least 2 places. So if it's lost from one place, it can be recovered from another. Deletion anomalies can result in data loss, emphasizing the need for careful deletion practices. By understanding and anticipating these anomalies, we can design databases that are more robust and resilient, and that serve our needs better. So the next time you're working with a database, remember to consider the potential for deletion anomalies and plan accordingly. Now that we understand the types of anomalies, how can we prevent them? The answer lies in a combination of strategic techniques and smart practices. First up is normalization. This process organizes data into tables to minimize redundancy and dependency. It's like tidying up your room. Everything has its place and there's no need for duplicates. By breaking down larger tables into smaller, more manageable entities and establishing relationships between them, we can significantly reduce the risk of anomalies. Next, we have the use of keys. These are the connective tissue of our database. Primary keys uniquely identify each record in a table, like a personal ID number. Foreign keys, on the other hand, establish relationships between different tables, referencing the primary key of another table. These keys work together to enforce referential integrity and ensure our data behaves as expected. Then we have consistent data entry. This is like the gatekeeper of our database. By enforcing data entry rules and validation constraints, we can ensure that only valid data gets in. This helps nip insertion anomalies in the bud. Another solution is the use of cascading operations. These are a bit like a domino effect, automatically propagating changes across related records when updates or deletions occur. This way, we maintain data integrity and prevent potential update and deletion anomalies. Finally, thoughtful database design plays a crucial role in preventing anomalies. This involves proper entity relationship modeling and careful consideration of dependencies and constraints. It's like planning a city. A well-planned city is more efficient and less prone to traffic jams, just like a well-planned database is less prone to anomalies. By addressing anomalies through proper design, normalization, and the enforcement of integrity constraints, we can maintain data consistency, accuracy, and reliability in our database systems. It's about creating a system that's not only effective but also reliable and user-friendly. After all, a well-structured database isn't just a pleasure to work with. It's also a powerful tool that can drive insights and decision-making. To wrap up, anomalies in database systems are inconsistencies or unexpected behaviors that can occur due to flaws in design, implementation, or usage. They come in 3 flavors: insertion, update, and deletion anomalies. Insertion anomalies create hurdles in adding data without breaching integrity constraints. Update anomalies lead to inconsistencies when modifying data. Deletion anomalies stir up unintentional loss of information upon removing data. To tackle these anomalies, a combination of strategies is employed. Normalization restructures data to minimize redundancy and dependency. The use of primary and foreign keys establishes relationships and enforces referential integrity. Consistent data entry rules and validation constraints prevent anomalies at the time of data insertion. Cascading operations maintain data integrity by propagating changes across related records. Lastly, a well-thought-out database design minimizes the risk of anomalies. Understanding and addressing these anomalies is key to maintaining data integrity and efficiency in database systems. Thanks for watching, and don't forget to like, share, and subscribe for more informative content like this.